Welcome to another video on my Arduino MegaADK, originally for Android, but I've left that away. Connected to breadboard with electronics and fischertechnik mechatronics. Last time, or the time before that, I decided to start all over, kind of. And concentrate on several individual circuits, because the behavior of the board and expected signals were not as I would expect by the program. So, to give a walkthrough, this fischertechnik mechatronics with an LDR is controlled by ultimately this pot meter, wired through the board speed. These wires go here, and that should diminish things. Well, it's not covered now by these rubber plates, so it has the full glimmering, as you can see. Then the motor is controlled by, well, by this of course for speed, but also this transistor circuit. Then pushing this button would light up this one. Pushing this button would light up this one. Then pushing this button would light up this LED. And you already see what's happening. It's already lighting up. So there's something wrong. Not to mention this, well, the wiring is alright, but I've left out the lamp for now, so these wires are doing nothing. This voltage divider is as yet, or for now, doing nothing. The motor is not completely wired, doing nothing. So what is doing anything? Well, like last time, I'm concentrating on this RC circuit. This is resistor, capacitor, push button, or more correctly a make button, LED, resistor. So what's the point? This circuit gets its power right here. Should it be? Yes, because the voltage from here, the yellow wire, is getting through this resistor to the capacitor. But since this is a make button, not a break button, this LED should not be burning. It should only burn when I press the button. Now, last time something happened that it suddenly started working correctly. But as you can see, not happening now. It's burning. Why? Well, let me break the circuit. Take it out, and you can see something is not quite alright. So it's getting its signal from somewhere else. Well, the only way it is connected is by the signal, or by the wire that would actually lead the signal from the LED to the board. So the signal is vice versa, is in the wrong direction. Again. So I'm going to slowly find out why things are the way they are, since also this LED should not be burning. Is this one burning? No, of course not, because the code that I wrote for having this all made, I threw it out. Well, I didn't throw it out, I started a new program. Anyway, that's introduction. Let's go to screencast and see how I maybe get things working or not. Well, then some surprise. I took a bit of time in between the introduction and this part and see what has happened. Yeah, well, this is incoming, this is outgoing as far as this circuit goes, and the signal is low, which also indicates this LED is off. So right now I am very curious what will happen if I actually press the button. Yeah, well, this is the expected behavior. However, also notice that at the start with a fully burning LED, the level of the signal was right here, which is 5 volts. Ugh. This is 5 volts, that was 5 volts, but now if I press the button, as you can see, it's 1 volt or 2 volts, kind of. So, yeah, it doesn't burn the LED, but why is this happening the way it is happening? Should I expect something else? Well, I would like to go back to the other program, but I'm not doing that for now. So this also means that, and I'm still talking about this part of the circuit. So right here, it got its power somehow from here, since this contact was broken. Yeah, break broken. Okay, it is a make contact, so it wasn't made. Let's put it to that. So the only way it got its power for high signal was from here. Well, this is defined as an input. Yes, analog in pin is definitely an in, and here also A5 for input. So it receives a signal, and it was sending a signal, most definitely. Alright, what else have we got to make? This is input. I want something else. Motor with propeller. The propeller isn't wired correctly, so let's find something else. This one isn't there as well yet. Okay, 7. That's a lens lamp. Oh, controlled by. Yeah, well, I can do something with a flashlight. So I'm going to control is that correct? Yeah, I'm just doing this. That's no problem. In this circuit it is controlled by, so when I have this one and the phototransistor, the signal gets out and this one sends a signal to this LED. What I'm going to do now is make this port 7 send a signal to this LED. As simple as that. So what I have to do now, simply copying, paste. Okay, wait. This is for the RC circuit, plus button plus LED to, which was it again, to A5. Okay, now analog pin 7. Oh wait, there's something else I should do, because that went wrong last time as well. Uh-oh. This is not good. So if you watch closely, it's hardly noticeable on camera, and I do regret that. Let me wait and watch right here. It's hardly noticeable. Even with the bare eye, it is a very short flash. Or is there something that makes it hard to watch? I think so. There's a wire in between. Let me get rid of this wire for a moment. Do it again. Yeah, now you can see it flash up just very shortly, but this is definitely not correct. Should be 255 and not 2. So this is bad. If I do it like this, what would happen? Alright, let's upload and try. What would happen if I now in the output in this situation? Let's upload. Alright, 0, and oh, it gives no output anymore. No, it should give output because I'm writing a value, but it says analog output pin 2, and that is not correct. This is a real problem, because 2, like here, 2 is the actual pin. This is a variable name that I assign to pin 2. So without analog pin 2 being assigned to 2, it doesn't do anything. Then I should remove here analog out pin 2 and replace it by just the digit 2. Then it will do something. Now this circuit doesn't do anything. This is a big problem. How is this possible? What I also can do, of course, since the input is used by 5, what is the input? analog in pin A5 is, and then let's be quick. A5. Oh wait, this should be a bracket. Okay, now I'm quite curious what will happen. Alright, let's go and find out. Uploading, done. So now it will give some input again. Yep, clearly. But what does the monitor do? A5 59. Yeah, right. And now I'm removing this. And won't do anything, I think. But let's see. Oh, it still says 59. That's remarkable. Yeah. See, now when I press the button now, it doesn't do anything because I removed the 2 right here. So it's not assigned to anything anymore. Ouch. Alright, some more musings. One of the things that I wonder about is why analog in pin A5 gives constantly 59 as output. And I wondered if that would be coming for A5 as when I treat it as hexadecimal, which is a wrong idea, because A5 hexadecimal, A is 10. Regard this as 16 to the power 0, and this is 16 to the power 1. A digit to the power 0 is 1, a digit to the power 1 is the digit itself. A hexadecimal being 10, so that would be 5, and A, which is 10 to the power 60 times 16 to the power 1 is 16, and 5 is 160. 5 plus 160 is 165 and not 59. So that idea is rubbish. Then you may notice that I changed this one to digital output, and I have added digital write high, only that one. So now let's see if this one gets high or only 7. High is burning bright, 7 is not quite so high. So let's see whatever that does. And 7 for... Oh wait, there's no 7 in, connected anymore. That won't work. Let's see, 7 would be where? Here to some LED. But 7 is right now here. So where is 7 going anyway? This could be better here. Going to an LED. So Oh wait, if I put this one here, what is coming from 6? Also an LED. So this would be correct then. Then the question is, where is my connection to 7, if anywhere? And now I've ruined this connection. Alright, there you go, kind of. So it is this LED. So I rather reprogram it to 6, being this small one. I don't mind. Let's just do that. So I change this to 6, this 6, and alright, let's go. Quick upload. Oh, I won't see here anything, of course, but I should be able to see. Oh, and look here, shining bright. So that works. Yeah, and these digits don't make any sense. But so let me press this. Yep, that works. And this one works as well. And I could of course extend it. Oh, that's a nice idea. Does delay work? How does it work? Delay is in milliseconds. So if I let it be up for 2 seconds, 2000 milliseconds being 1 second, and low, and another 2 seconds, or make that 3, I don't care. No, 2 is okay, 2 will be fine. So blinking LED, and let's see. Oh, then it would be nice if I put a probe on it. On the other hand, no need to, because it is doing its job. 2 on, 2 off. And then this one again. Yep, working. Which means it actually does do its job. What I wonder though is what would it do on serial terminal? So that is what I'm going to do anyway. And the same thing here, because I'm massively interested in the outputs it gets. And this is not correct. This won't work. This will. Alright, let's see how far we get now. Okay, Go figure. It is shining brightly, but digital output, the digital output in 6 gives 6. Not high, not low, 6. And this one is still working. Although you really have to look very careful. Let me get this wire out of view again. A very faint light, but it does work. And this makes absolutely no sense. But things do work, electronically speaking. So where are those crazy values coming from? That I have no idea. So with this very peculiar stuff going on, the values of the ports outgoing and incoming, outgoing right here, incoming here, and they don't make sense, the values. Then, well, I have this one high and low, which works. I have this one kind of working. Just a very short flash, but at least it works. Why the odd values? I have no idea. The other Arduinos that I have respond for now nicely. Did I blow something up? No idea. It suddenly worked, but well, blowing up happens suddenly, not gradually, usually. So with all the other circuits that there are, I have to check them out if they still want to work. And of course it all started with pulse width modulation. Now the output of the ports, and then of course I mean these ports on this side here, they are, or those outputs are by definition, in the case of Arduino, pulse width modulated. So, well, not this part, this is communication, but this is pulse width modulation. So that should be nice, measurable, but as far as I can see, there's no pulse width modulation there. Anyway, that's it for now. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment if you like. Maybe a solution, who knows. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Show your appreciation and support by making a small donation. More information on my website, which you can find under this video, or rewind and look at the start of this video. And you can also choose to become a patron and have your name mentioned either on my website or on my website, and with the video in several ways depending on the pledge you make. And this is obviously going to be continued. So once again, thank you for watching.